Assalamualaikum. Um, Assalamualaikum everybody. My students in our class BEE 4233 Data Communication. So we meet again in this another video. So in this video we will discuss about chapter 3, which we will discuss about OSI 7 layers principles for data communication and network. Okay, so basically this chapter we will cover these subtopics. First, layer by layer protocols, principles and architecture. Okay, second, data communication interface and networking. Third, data segmentation and reassembly. And four, error detection and correction. Okay, so if you need additional information, you can click this link, okay, later on. Okay, first subtopic, layer by layer protocols, principles and architecture of OSI principles. Okay, first, for introduction, for discussion, what is the difference between OSI and ISO? So the layering model is OSI, which stands for Open System Interconnection. So OSI is Open System Interconnection. ISO, the organization that developed the model, is ISO, which is stand for International Organization for Standardization. ISO, International Organization for Standardization. Okay, under this ISO there is ANSI, which is stand for American National Standard Institute, is a member of ISO. ANSI farms out much of the hardware standardization for the IEEE. So ANSI works with IEEE, which these bodies is member of ISO, contribute much of the effort in hardware standardization for communication. Okay, so you can read about ISO in this website or on the internet. ISO is an independent, non-governmental international organization with a membership of about 164 national standard bodies. Okay, you can Google more about ISO. So today we will discuss about OSI 7 layers, right? So these are the layers, names and numbers of layers in the literature. So we have many models, and these models have various numbers, okay, different numbers of layers. So what we are discussing in this chapter is about OSI 7 layers. Okay, you can see the topic. So besides that, we have RFC 1122 Internet STD3 4 layers. Cisco Academy, 4 layers. Kurose Forozan, 5 layers. Comm Kozirok, 4 plus 1 layers. Stalling, 5 layers. Tanam Bomi, 5 layers. ARM, ARPANET Reference Model, 3 layers. And last but not least, OSI Model, 7 layers. So we will focus this chapter, our discussion about this 7 layers OSI model. So you can see the difference between the naming and the layers. Okay, so for example, this Internet STD3, there are 4 layers: applications, transport, internet, and link. In Cisco Academy, application, transport, there is internet network and network interface. Nama dia lain. The naming is little bit different. For Ferozan and Kurose, 5 layers model: application, transport, network, data link, and physical. Okay. For Comm, 4 plus 1. Okay, it is known TCP/IP 5 layer reference model: application, transport, internet, data link, and hardware. So there is similar. Application, transport, similar. Network is different. This is in Corozet, we call it internet. In Forozan, they call it network. Data link, similar. And physical, in Forozan they call it physical, but in Corozet they call it hardware. Physical, hardware is sometimes it is similar, but the naming. Installing, there are 5 layers: application, host to host, transport, internet, network access, physical. Okay, in this Tannenbaum TCP/IP 5 layer reference model: application, transport, internet, data link, physical. So many are calling the hardware physical layer. For ARPANET, there are 3 layers: application, host to host, network interface. Okay. However, we will concentrate our discussion on OSI model with 7 layers, which consists of the calculation starts from the physical, from the hardware. So we have 1, 2, 3, 4, 5, 6, 7, like that. Okay. Physical, data link, network, transport, session, presentation, and application. So that is the 7 layer of OSI model. Some of the networking models are from textbook, which are secondary sources that may conflict with the intent of RFC and other ETF primary sources. Okay, tak apa, abaikan. Open versus proprietary. What is the meaning between open and proprietary? Open means specifications are public domain. It requires committee agreement. However, it can be slow for implementation. On the other hand, proprietary means privately owned and controlled. Specifications are kept private so that other companies cannot duplicate. No outside agreement needed. Can be reactive. So therefore, because it is owned and controlled by privately by a company, so it can be faster for implementation. Consumers prefer open and standardized system. The people like open but standard system, as this allows them to use the product of various manufacturers. Sometimes it takes too long to come up with them. Ini cerita macam which you can relate about the charger. You can relate the hardware. Example, charger between iPhone vs Android phone. Okay, so one is open Android and proprietary iPhone. It is privately owned and controlled. Specification dia lain daripada Android. Itu je lah. Layering and interfacing. Layering is an important concept in computing. When a user runs an application, the user interface with application. Okay, the user interface with application. The application interface with operating system. Okay, the operating system interface with BIOS. And the BIOS interface with the input-output hardware. Okay. So what do you know about BIOS? What is BIOS? Okay, let me check. What do you know about BIOS? BIOS in full is basic input-output system. Okay, the operating system interface with BIOS, and BIOS interface with input-output hardware. So BIOS is the system. The user need only know something about the application and doesn't need to know any details about the operating system, the BIOS or the hardware. Similarly, the application needs information about the user and the operating system, but not the BIOS or hardware. For layering to be successful, there must be a standard interface into a layer. The operating system is said to provide an application programming interface, API. So API is application programming interface. More than just a way of thinking about it. These layers can be seen in the industry. So you can see clearly the fragmentation in the industry. Some companies are specializing in hardware. For example, Seagate, Maxtor, Western Digital. Ini ialah drive kan, hard disk, hard drive. Example lah. Okay, so some companies are specialized in hardware. Some companies are specializing in BIOS. For example, AMI, Phoenix, etc. Some companies are specializing in OS, operating systems. Okay, example, Microsoft, Sun, B, etc. And some companies are specialized in application. For example, Oracle, Microsoft, AOL, etc., etc. Maybe you can relate. You can think of your own. What are the companies which you can relate in specializing in application, operating systems, BIOS, and also hardware. I'm sure that there are, some other than I mentioned here, other companies which are strong in those different areas. Okay. Communication layering. The communication between two or more users on a network similarly is broken down into layers. A possible model for this layering was laid out by the ISO. So what is OSI? The thing that we going to discuss lah. OSI. OSI serves as a reference model for how information is transmitted between any 2 points in a network. It guides manufacturers or vendors so they can make products that will work with other products. The OSI model is comprised of 7 layers. Kita nak discuss. This is what we're going to discuss in this topic. The OSI model is comprised of 7 layers that are involved in communication between two nodes of a network. Involved in communication between two nodes in a network. It is not the law. The OSI model was never adopted as a rigorous set of specification. The lower layers, okay, tengok ni. The lower layers, so meaning ada upper layers. The lower layers of OSI, which is physical, data link, network and transport. There are 4 lower layers. Physical, data link, network and transport are for the most part adhered to. So recall that we have already mentioned a broader a broader which serves as both bridge in data link layer and router in network layer. So you have data link network. There are one device called router, which combination of bridge and router. Bridge plus router become router. So bridge are in data link layer, and router in network layer. Okay, we will see after this what are the function of this device. The OSI purpose. Even if manufacturers do not restrict themselves to a particular OSI layer, they usually think of and describe their products in relationship to the OSI model. It provides a language and framework for discussion of network, so it persists and continues to be taught, to be understood. Next is TCP IP model. Another model for understanding communication networks is called TCP IP model. Okay, what is TCP IP model? So what is the meaning of TCP IP? Okay, TCP IP stand for Transmission Control Protocol, Internet Protocol. Sorry, sini. TCP IP is a transmission control protocol, Internet Protocol. Okay, so another model for understanding communications network is the TCP IP model. It is also broken into several layers. It has no equivalent of OSI model physical layer. Okay, physical layer tak ada equivalent dengan OSI. The next three layers of OSI model and the TCP IP model are roughly equivalent. Okay, you can see this in our previous slide. The top three layers of OSI model are combined into one layer in the TCP IP model. The top three layers of OSI model is equivalent to only one layer in TCP IP model. Okay, so tengok kat mana combination tadi. Sini. Mana? Ada situ. Okay. The main idea, the communication between computers can be broken down into layers. Each layer is characterized by its function and how it interfaces with adjacent or with next layers. Within the source's computer and starting at the user level, the communication is passed down through the layers to the lowest layer where it is sent through some transmission medium. Okay. The communication travels at the lowest layer, physical layer. The communication travels at the lowest layer, the physical layer, occasionally rising up to the second layer, bridge, or third layer, router, until it reaches the destination. The communication now passes up through the layers. So basically, when we're talking about physical layer, traveling in the physical layer means the signal is sent through wires or cables, or sometimes we call it fibers. That is the lowest layer or the physical layer. Okay, so these are the summary of 7 layers of OSI model. Okay, so 7 layers of OSI models, which is start from the physical. First layer is the physical layer, second layer is data link layer, third layer is network layer, fourth is the transport layer, fifth is the session layer, 6 is the presentation layer, and last is the 7 is the application layer. So so that's all. Hope you can remember this layer, the sequence 1 2 3 4 5 6 7, which one is upper, which one is lower layer. Okay, so until then, that's all for this part of the video. We will meet again in the next video. So thank you very much for your attention. Hope you can get something from this video. That's all. Until we meet again in the next video. Thank you very much. Bye bye.